Well, good afternoon, everyone. Welcome to my thesis presentation entitled Hematological Profiles Associated with Productive Performance and Estrous State in Grass-Fed Beef Heifers. I'll be following a typical scientific outline, followed by some of my master's experience at the end. Feed costs and reproductive losses are two expenses affecting profitability in the beef industry. Improvements made to feed efficiency and also to estrus detection may share linkages with energy metabolism. Improvements made to feed efficiency can be accomplished by residual feed intake, or RFI. This was first described by Koch in 1963 as the actual feed intake subtract the predicted feed intake. RFI is considered to be a heritable trait, which could lead to the widespread improvement of feed efficiency within the industry, within the Canadian industry and globally. To further understand feed efficiency, we can study the differences in the energy metabolism between animals. Understanding the underlying biology by measures such as hematological measures can help to identify feed-efficient phenotypes, which could be used to select the feed-efficient genotypes. For the lifetime productivity of a reproducing beef cow, the heifer should reach puberty at the appropriate age so that the heifer can have enough estrous cycles prior to the first breeding season to allow her to have that first calf. But this relies on successful estrus detection, especially for technologies such as embryo transfer or artificial insemination. Hematological measures serve as an appropriate medium to study differences in energy metabolism. Considering the blood circulates throughout the body and comes in contact with various tissues and organs, and is also the site of various biochemical reactions. In the literature, the complete blood count has been associated with energy and metabolism, as well as differences in immunoglobulin response, and as well as the blood plasma metabolites. Factors which also may influence energy metabolism include factors such as age, body composition, and body weight, as well as physiological stage, including pregnancy and estrus. It was hypothesized that identifying hematological measures associated with feed efficiency and estrous state may lead to an increased understanding of the biological processes associated with metabolic fluctuations and identify proxies to these complex traits. The objectives were to evaluate the CBC, specific IgG1 and IgM response, and blood plasma metabolic profiles relative to feed efficiency classification in forage-fed replacement beef heifer calves as well as pregnant beef heifers. Also to characterize the blood plasma analytes in terms of the estrus and non-estrus state, and to compare the metabolic profile during estrus in relation to age, feed efficiency, body size, body fatness, and leanness categories. The first study, associations between blood cells, immune response, and plasma metabolic profile with productive performance and grass-fed replacement heifers, was submitted to the Journal of Animal Production Science and has been accepted with further revisions. The complete blood cell count is a routine assessment used to evaluate the health status of an animal. And it evaluates parameters such as those related to red blood cells, white blood cells, and also looks at the protein profiles of the blood sample. For the humoral immune response, it has been shown previously that animals with improved immune function also have an improved productive performance. And this has been assessed using responses of the immunoglobulins to a foreign antigen. We also created a list of 26 parameters that were associated with various tissues and processes which could be further related to energy and metabolism and related to feed efficiency. To do this, 107 heifer calves and 31 pregnant yearlings were sourced from 19 maritime beef producers. They were put on feed tests for 124 days, and their performance tested roughly every 30 days. The diet was composed of 99.5% haylage with a 0.5% vitamin premix, and they were assessed for hematological measures, the CBC analysis, an immune system challenge, and the metabolic profile. The breed composition was determined for each heifer. via hair follicle DNA extraction. This used a 50K single nucleotide polymorphism chip, and the estimation of the individual population breed allele frequencies was compared using pairwise comparison. And the breed composition of the heifer calves shown on the top was primarily Angus, and the pregnant heifers were primarily Polled Hereford. The timeline of the evaluations: the performance evaluation was completed every approximately 30 days. This included taking the body weight, body composition ultrasounds for back fat, rump fat, marbling, as well as ribeye area, and also taking a blood sample. At both the start and the end of the feed testing, the CBC analysis was completed on each heifer, and about midway through the feed test, the immune system challenge was completed between days 56 and 77. For the humoral immune challenge, initially a blood sample was taken to get the baseline immunoglobulins. This was followed with a vaccine to ovalbumin protein. This was followed 14 days later by a blood sample to determine the primary response, which was followed again by a booster of ovalbumin, and finally in 21 days, a final blood sample to get the secondary immunoglobulin response of IgM and IgG1. The R5 models used for the heifer calves and pregnant heifers accounted for average daily gain, body weight, as well as ultrasound traits and age, and in addition for the pregnant heifers included days in gestation. For the statistical analysis, the normality was tested and ensured, and the general linear model of SAS was used to compare the productive performance traits, which also used breed composition of each heifer, and for the CBC parameters, which was split in population into halves, and the immune parameters, which was also split into halves and into thirds. For the repeated measures over the duration of the trial, a mixed procedure was used using the following model. For some results, mean corpuscular volume and mean cell hemoglobin was higher in the inefficient heifer calves. What this may be related to is an increased demand of oxygen in the less efficient heifers, and may suggest a lower oxygen carrying capacity in animals which are more feed efficient. With the white blood cells, the safe amount of neutrophils were higher in the inefficient heifer calves as well as the pregnant yearlings. And this may be related to the susceptibility to stress, as been shown previously, of animals that are less feed efficient. Lymphocytes were higher in both the feed efficient heifer calves as well as the pregnant yearlings, which may be, as I mentioned previously, related to the lower demands of oxygen by animals which are more feed efficient, which may provide more oxygen available for oxidative phosphorylation, production of ATP for the lymphocytes. For the immune response, in terms of heifer calves and pregnant heifers, the pregnant heifers had a greater secondary IgM response, which is likely related to the age of the pregnant heifers, able to produce greater concentrations of immunoglobulins. In terms of feed efficiency, heifers which had greater feed efficiency had a greater secondary IgM response, which suggests there may be improved immune function here with heifers that have improved productive performance. For the metabolic profiles, in the heifer calves, phosphorus was higher in heifers which were more feed efficient, which may be related to the production of ATP. Alkaline phosphatase was also higher in the inefficient heifer calves, which due to the differing isoforms of alkaline phosphatase, in this case it may be related to the growth stage of these heifers. And plasma potassium was higher in efficient heifer calves, which may indicate differences in protein synthesis in the two groups during the stage of growth. In the pregnant heifers, cholesterol was higher in the inefficient heifers, and as well as non-estriated fatty acids towards the end of the feed test, which may be related to the stage of pregnancy in these heifers and the switch over from lipogenesis to lipolysis. Alkaline phosphatase was higher in the efficient pregnant heifers at this point, which may once again be related to the isoforms of alkaline phosphatase, which may be related to the uterine production in this case. Creatinine was also higher in the efficient heifers, which may be a source of energy during this point in pregnancy. And in conclusion, hematological measures have the potential to be used as indirect assessments of feed efficiency in peripubertal heifer calves and pregnant yearlings. Higher concentrations of potassium and phosphorus in the efficient heifer calves may explain the greater efficiency during stages of growth and development. The efficient pregnant heifers appear to have reduced metabolic demands of the liver during pregnancy, as indicated by lower concentrations of cholesterol and globulin. And physiological state should be taken into consideration when measuring hematological measures identified for proxies of feed efficiency. For the second study, the metabolic profile of beef heifers during the estrous and non-estrous state was prepared for submission to the Reproduction in Domestic Animals Journal. During the estrous state and the estrous day, higher concentrations of estrogen as well as fluctuations in LH and FSH result in the release of a follicle which will wait to be fertilized, which increases the concentrations of estradiol as shown here, which increases the signs of, which promotes the signs of estrus. This includes physical signs such as vulvar swelling, mucus and color, as well as mounting marks. Behaviorally, mounting and bellowing, as well as hormonal related to progesterone and the other hormone profile. Some common estrus detection methods used in the industry include pedometers used to track changes in activity, ultrasonography for the stage of the corpus luteum, infrared imaging to assess temperature around the vulva and muzzle area to identify differences in body temperature, as well as some practical assessments practical indicators used by the industry, such as tail painting or estrus detection software and systems, and visual indicators such as the camera patch in the bottom right. These assessments can be further enhanced or complemented using additional assessments such as hematological measures. To do this, 107 heifer calves were observed for estrus twice daily for 124 days. The feed intake and productive performance for body weight and body composition, similar to the previous study, were completed every 30 days. Feed efficiency, again, was determined using RFI, and the blood samples were collected during signs of estrus and every 30 days. For the estrus detection methods, heifers were observed both in the morning and the early morning and evening hours for signs such as mounting activity, bawling, and restlessness. We also used the Estrotec patches on the back of each heifer, where we observed any color changes or scratching on these patches. If this was observed, the heifers were brought inside to the handling facility where they were further assessed for physical signs of estrus, including vulva color, edema, as well as mucus. If the heifer was considered to be in estrus, a blood sample was taken from the jugular vein, where plasma progesterone concentrations less than 0.6 nanograms per mil were considered in the estrus state. And the metabolic profile was assessed in the estrus samples as well as the non-estrus samples. For the statistical analysis, the normality was tested and the transformations were completed where necessary. The GLM procedure was used to compare the metabolic profile during the estrus and non-estrus state using the following model, which also accounted for breed. The plasma metabolites were also compared against the extremes of the phenotypic classifications. This included age, body weight, the ultrasound measures, as well as RFI. The logistic regression procedure fitted all of the analytes that differed in least square means between the estrus and non-estrus states in order to determine the estrus probability using plasma metabolites. And the variation of the plasma metabolites in relation to RFI was determined using the variance importance analysis procedure to observe the differences in the metabolic profile and variation in feed efficiency. For the results, calcium, sodium, and osmolality were all lower during the estrous state, and this may be related to the changes in the total plasma volume during the estrous state. Globulin and total protein were also reduced during the estrous state, which may be associated with changes in protein turnover. Beta-hydroxybutyric acid was increased during the estrous state, which may be associated with a greater mobilization of lipids and energetic shift during the estrous state. Alkaline phosphatase, aspartate aminotransferase, and creatine kinase were increased during the estrous state, which may be related to increases in liver activity suggested by ALP, and as well as increases in muscular metabolism as suggested by AST and CK. T3 was higher during the estrous state, and what's interesting about T3 is that there's several associations between T3 and the other amyloids that were different during the estrous state, such as plasma ions, AST, ALP, and BHBA. There was also a logistic regression. For estrous probability, the plasma metabolites, ALP, AST, BHBA, CK, and T3 can increase the certainty of identifying the estrous state by 91.5%. By using T3 alone, you can increase your certainty of detecting estrous by 3 times. In heifers which were younger and leaner, greater concentrations of globulin, total protein, and creatine kinase during the estrous state also indicates greater protein turnover in these heifers. In the heavier and the fatter heifers, lower concentrations of sodium and osmolality may be related to the body composition of these heifers. Considering that there is less water in the adipose tissue, this may be related to the dissociation of the ions in these tissues. In terms of feed efficiency, the amyloids that are over the line showed here in the middle vary according to feed efficiency. For example, cholesterol showed some of the greatest variation along with feed efficiency, which was followed by GGT and as well as GLDH. And interestingly, phosphorus and potassium were also associated with feed efficiency here in this case, which was similar to the previous study. In conclusion, the estrous state is strongly associated with fluctuations of ALP, AST, BHBA, CK, and T3. These amyloids, especially T3, may increase the certainty of identifying the estrous state in heifers, and the effects of age, feed efficiency, body size, and composition should be taken into consideration when assessing these traits in heifers. Finally, for the general discussion, the results of the metabolic profiles from the first study as well as the second study are summarized here in this figure. What you can observe here is the differences in the metabolic profiles in terms of both energy metabolism as well as physiological state. So here in the first circle, there's differences in the pregnant heifers, inefficient as well as the efficient heifers, and the heifer calves in terms of feed efficiency, as well as during the estrous state, which can provide a more extreme view of these shifts in energy metabolism, which may be related back to feed efficiency. I'd like to thank my coworkers that put a lot of work into this project, including over 32,000 kilometers of travel back and forth to the farm and over 3,000 hours of work. I'd also like to thank my advisor, Dr. Yuri Montagnoli, as well as my committee members, Dr. Alan Green and Dr. Kendall Swanson, as well as Dr. Neil Caro from the University of Guelph. I'd also like to thank the staff at the Maritime Beef Testing Society, as well as the maritime beef producers who loaned their animals for this research two summers ago. I'd also like to thank our funding agencies. For my master's experience, I was very fortunate to be able to present at the Canadian Society of Animal Science Conference in Ottawa, as well as the European Federation of Animal Science Conference, which was held in Warsaw, Poland. And I was able to present at the Livestock Gentech Conference, which was held in Edmonton, Alberta this past year. During my master's, I also tried to remain involved within the industry. We did some extension work with maritime beef producers, producing a number of reports. I was honored to be selected as a Cattleman Young Leader this year as part of their mentorship program, shown here with my mentor, John Baker. And I spoke about my experience with this program at the Maritime Beef Conference, which was held in Moncton, New Brunswick this year. And I just returned back from Montevideo, Uruguay, where I took part in the World Hereford Conference and expanded my network globally.